Scientific notation. Scientific notation is used to write very large numbers or very small numbers without all the zeros. For example, in standard form, we have 523 million, or in scientific notation, we have 5.23 times 10 to the 8th power. The form of scientific notation is a number part times 10 to a power. The number is greater than or equal to 1 and less than 10. Or another way to say it is it always has one non-zero digit on the left of the decimal. To put numbers into scientific notation, step 1, find the appropriate place for the decimal. Step 2, use the X for times. Step 3, write 10 to a power. The power is the number of places you would have to move the decimal in the new number to get back to the original. If you would move to the right, it is a positive exponent. If you would move to the left, it is a negative exponent. Let's look at an example. Write 372 million in scientific notation. The first thing we have to do is choose the place for the decimal. The decimal has to go between the 3 and the 7. That will give us one non-zero digit on the left of the decimal, so a number that is between 1 and 10. That's the only place that the decimal can go. If it's after the 7, we would have 37. That's too big. If it's in front of the 3, that would be less than 1. That would be too small. So that's the only option for the decimal. So we have 3.72 our times 10, and then we'll choose our exponent. From here, our decimal, we have to go back to the original decimal. We'll count the spaces, and we would have to go to the right. So it's going to be positive, and it's going to go 8 spaces. Another way you can think of it is this is a very large number. You might think of a large number, a positive exponent, a large number. Let's look at another example. Write 0.0000712 in scientific notation. So this is a very tiny number. First step is to choose where the decimal should go. The decimal has to go between the 7 and the 1. That is the only choice. So we'll have 7.12 times 10, and then we'll choose our power. From our new decimal, to get back to the original, we would have to go to the left. So we're going to have a negative exponent, and we can count 1, 2, 3, 4, 5, 6. Or we can remember this is a tiny number, so it will have a negative exponent. Let's look at one more example where we can see the advantage of writing in scientific notation. The mass of a protein is approximately, and we see this extremely small number. Write this number in scientific notation. So our first job is to find the place for the decimal. It's going to go between the 1 and the 7. So we'll have 1.7 times 10, and very small number, we're going to go to the left to get back to the original, and we'll count 3, 6, 9, 12, 15, 18, 21, 24. So a negative 24. If you had to do some other operation with this number, like a scientist would have to, it would be much easier to operate with this number that's in the scientific notation than it would be with all the zeros. So this is the purpose of scientific notation. Standard or decimal form of a number. To convert numbers from scientific notation to decimal or standard form, you will perform the multiplication. Multiplying by a power of 10 moves the decimal to the right for a positive exponent and to the left for a negative exponent. We're going to convert to decimal form. This is also known as standard form. So we will just apply the multiplication. When we multiply and we have a negative exponent on our power of 10, it will move our decimal to the left 3 places. So we're going to move 1, 2, 3. So we're going to have to add some zeros to have enough spaces. So we moved 1, 2, 3 places, and make sure that you do write your decimal. Let's look at another example. Convert to decimal form, which is also known as standard form. 1.201 times 10 to the 8. This time we have a positive exponent, so we will move our decimal to the right 8 places. So if we start, we have 1, 2, 3 places. We're going to have to add 5 zeros to have enough. So 1, 2, 0, 1, and then we'll add 5 zeros. 1, 2, 3, 4, 5. So our decimal was between the 1 and 2. 1, 2, 3, 4, 5, 6, 7, 8. Now our decimal is at the end. We don't have to write a decimal after the number. We can put commas so that the number is easier to read. And so that number is actually 120,100,000.